Hello, this is section 5.1. I know we're doing this at the end of this unit, but it is dealing with probabilities, and it's something we've kind of talked about before a little bit with simulations. Instead of just using simulated data, we're going to actually talk about how you can make a simulation, do a simulation. So, section 5.1, this is just day one. Quick definition for you. A simulation is the process that models an event that can't be calculated or is too difficult to calculate to get good estimate of the theoretical or actual results. So the situation might be too hard to actually do, so we're going to try to simulate it and model that event with this simulation. All right? Now, when we're dealing with simulations, there are specific steps that need to be followed, and this is straight from the College Board. Okay? I'm going to show you those steps, and these are worth writing down. So, simulation steps. Clearly state the problem. Okay? From the situation, what is the problem we're dealing with? For this course, it'll be given to you typically. On an AP test, you probably won't need to write it out, but get in the habit of doing it in case you do. Number 2, define the key components. Okay? Same deal here. You probably won't need to write this out, but we're going to do it to get in the habit of it. Number 3, state the underlying assumptions. Again, on the AP exam test, you probably won't need to do this, but you will have to do it for multiple choice questions, so we're going to do it now. Usually this is what we're assuming, what probabilities we're assuming. Now we get into things that you for sure have to be able to do. Select a model. Define a specific trial. What is the trial going to look like? And then actually conduct 3 trials and explain what it means in terms of the problem. And then we're going to state that we want to repeat it for at least 25 times. We're not going to do that. You just have to do it at least 3, but then you can summarize the information and make conclusions. So again, 4, 5, 6, and 8 are required for like an FRQ by the College Board. Some of the other ones might be required when it comes to a multiple choice. Now, let's talk about a couple of these things. First of all, what models are good. And it's got to be some model of randomization. So it could be flipping a coin. These, again, typically only work if it's like, if we have a 50% chance of something. Okay? When you die. Again, this is good. And again, these are good for independent events. But this only works if you have out of 6 probability. If you do, perfect. Let's use it. Because those are typically easy to do, to simulate. Random number generator is going to be a big one. We just have to define how we're using it. And we'll get into a random number table probably in the next lesson. But those are the main ones that we'll use. All right? So let's get into our first situation here. All right, so here's the situation. Mary has not studied for her history exam. She knows none of the answers on a 7-question true-false exam and decides to guess at all of them. Estimate the probability that Mary will guess the correct answers to 4 or more of the 7 questions. Okay? So we want to use a simulation to do this. Now, if you go back to our 8 steps, state the problem, define the key components, and state the underlying assumptions. We are going to do that. Excuse me. This is the problem. Bingo. Number 1 is done. Number 2, the key components. Okay? In this case, we're just looking for what is the most important, like what is the underlying question we're trying to answer, the key question, I guess we could say. Does Mary guess correctly? That is the basic idea here. Okay? Now there are some underlying assumptions. So that's going to be number 3. We are assuming that the probability that she gets it correct is 0.5. She has a 50% chance. The probability that she gets it wrong, or I guess we could say incorrect, is also 0.5. So we're stating some assumptions in probabilities. But we also want to just assume that each question, all guesses, are independent. Okay, it's worth noting because one should not affect the other. So now we're into number 4, the model. We need to decide a model that will work to help us actually simulate this. And if it's a 50-50 chance, best option, flip a coin. So I'm going to use the flip a coin model. Now when I'm talking about this model, I need to actually state what is what. So I'm going to say heads is correct, tails is wrong. Okay? Now, number 5 gets us into actually defining a trial, and then doing it 3 times would be number 6. So if we want to flip a coin, now there are other options. You could do like roll a die and just say 1 through 3 are correct answers, 4 through 6 are wrong. You could do a random number generator for 1 and 2. 1 is correct, 2 is wrong. There's options. We're going to use flip a coin. So our trial. So number 5, our trial. I want to first define it. So what we're going to say is what we're going to do. We're going to flip a coin. 7 times for heads or tails. Okay, and that will give us 1 trial. That's defining 1 trial. That's not 7 trials. That's 1 trial because it's like simulating 1 test of 7 questions. Okay, so now we actually have to get a coin. You can use a real coin. You can use a coin that comes up on ProbSim on your calculator. There's different ways to do it. What I'm going to do is, I actually already did it. I actually flipped a real coin. So I'm going to state my 3 trials. This is number 6. You actually should conduct 3 trials and explain what they mean. Okay? In context. So if I want to do that, my first trial, actually, I will list them all here. So trial 1, trial 2, and trial 3. Here we go. There's my results, okay, from each of the 3 trials. Now, I'm going to just circle the ones of correct. So in trial 1, 3 of them were correct. In trial 2, 1, 2, 3, 4 of them were correct. In trial 3, 1, 2, 3. Now, putting context to that would just be saying for trial 1, it was 3 correct, 4 wrong. That's enough for that context. So just so we know what that actually meant back to what we're saying, because we said heads was correct. So this one is 4 correct, 3 wrong, and this one would be 3 correct, and 4 wrong. All right? So that is step 6. Now, we would have to repeat it for at least 25 trials. We want to get a good sample size. We want at least 25 trials, and I'm just going to right now make a note, then repeat for 25 trials, and record. You do not have to, you do need to do 25 trials. So like if you're doing a homework assignment, you can work with a couple partners and just divvy it up so you have all of the, at least 25 of them. But you don't have to write out every single trial. What you can do is just kind of what I'm going to do here. How frequent out of these 25 did you get 0 guesses correct all the way down to 7? You can do it on a sideways T-chart. I just did it this way. So I'm going to give you my data. There was 1 time where it was 0 correct. 1 for 1, 1 for 2. I actually had 5 for 3. For 4, I had, I believe it was 10. For 5, it was 4 times. 6, it was 2 times. And again, the ones that I just did, I had a 3, a 4, and a 3. And then I had none for 7. So let's see if that adds up. 15, 20, 24. So maybe it was one more for 4. Can't see my own numbers. So we're going to go with that one. So that's my data. You can kind of see a distribution there. I want to now summarize my results. Now, if we talked about the question was, does Mary guess correctly? We want to know how many times she guesses 4 or more correctly. Well, I can circle the ones that she did. 4 or more was all in here. So that was 17 out of 25 times. There's a lot. So that's a pretty high chance that that's going to happen. So the probability that Mary will guess 4 or more questions correct is 17 out of 25, which gets me 0.68 if I'm putting it into a decimal, or 0.680. So I would then summarize by saying we estimate that Mary has, you can say around, we don't want to put it exact because this is just based off of trials, around a 68% chance of guessing 4 or more correct. All right? Sometimes you may be asked to find the mean, but we're just looking for the probability for this one. So there's a simulation. Now I'm going to try another one, and I want you to look at it and try to do some of these steps on your own. So I would ask you to pause it. So I'm only going to do one more example in this video. And I want you to think about all these parts. So go at step at a time. The problem is given. But I want you to start to identify what is the key component, what are the assumptions, what would be your model that would be easiest to use, and then we'll go from there. So it says, Joe drives a minibus in his town. The bus has 8 seats. People buy tickets in advance, but on average, 10% of those who buy tickets do not show up. So Joe sells 9 tickets for each trip. Sometimes more than 8 people show up with the tickets. Estimate the probability that this will happen. So he only has 8 seats, but he's selling 9, assuming that there's going to be at least one who doesn't show up. But what happens if there is? Then you have an issue. So we want to know the probability that that will actually happen, where more than 8 would show up. So meaning 9 or 10. And well, I guess he only sold 9, so only 9 would. Yeah. So what's the probability that 9 would show up? And then we want to see, like, based off of this estimation, is it good? Is it okay that he's selling 9 tickets for each trip? Is it likely to backfire? So I'd like you to start and come up with those other 7 key components here. So why don't you pause and try this? All right. So the key component is never like specifically like it has to be word for word this. But really we want to kind of encompass what we're going to do with our trial. Like, what are we actually testing with our trial? And this one we're testing whether someone shows up or not each thing. Okay? So our assumptions would be that the probability of showing up is 0.9 and the probability of not showing up is 0.1. Right? It's that 10% of people who buy a ticket don't show up. So there's our no-show probability. That means showing up would be 90%. Now, you can choose the model, but if there's a 9%, 10%, rolling a die isn't going to be great because there's out of 6. So that's like 90% and 10%, that's out of 100 or out of 10 you could do. Flipping a coin also is not going to work because we don't have 50-50 chances. So you got to go to a random number generator or a random number table, most likely. I'm going to use the random number generator because I think that's the best, and it's usually usable for a lot of things. So we're going to use the random number generator. That is my model. But I need to define the parts of this model. So I'm going to use numbers 0 through 9. I'm going to keep it all one digit. You could do 1 through 10 if you want. We just need 10 numbers to show the 10% chances. So like, I'm going to say that 0 is my no-show. And then I have, so that's 1 of the 10. So that's 10% no-show. Then I'm going to use 1 through 9. That's 9 numbers is going to be my show. And that gives me my 0.1 and my 0.9. Now I'm going to actually do this. So my trials, I'm going to randomly generate. We'll do 9 numbers because I sold 9 tickets. 9 numbers, 0 through 9. Okay. The reason I'm doing this, again, just as a side note, why am I doing 9? For each ticket sold. Okay, 9 tickets sold. I'm hoping that at least one of them is a no-show. So I did this. I randomly generated. I went to my random number generator. No repeats. Well, we could do repeats. Yeah, we do want repeats. So, because it could be any of the numbers. We're just trying to see if any of them show up as 0. Because there could be more than one person who don't show up. So these are my three trials that I did. And my 3 trials, if I look at the specific numbers, I said 0 is the no-shows. I've got 2 no-shows here. Okay, 2 no-shows. I've got 2 no-shows for this one. Never mind, I fixed it. I wrote one of those numbers wrong. This was actually only a 1 no-show. It was 1 no-show though, so that was good. And this last one, there was 2 no-shows. So that's my context. The question is, will we have enough space? So we need to do up to 25 trials. So make a note. Repeat for 25 trials. You do not have to state all those trials, but you do need to get your data. So number of people who showed up. So maybe I should change that down here. So 7 showed, 8 showed, 7 showed. So I've got 7, 8, and 7. But I can go and I can either do this myself or I can partner up and get this data so that I can have 25 trials worth. And that data looks like this. So even though my 3 trials had enough no-shows where it will work on this bus, this minibus, but if I went 25 times, I see 11 of them had too many people show up. That's 11 out of the 25. That's not looking great. It's an awkward 11 times if I don't have room for one of those people. So I'm going to summarize this by saying the probability that more than 8 people will show up was 11 out of 25, which is 0.44 repeating. So I would just give some context. The estimated, probability that Joe oversells is 44%. He's thinking he can sell more and make some extra money because people won't show up, but that's 44% of the time you've got that issue. And that's just from our trial. Now that's an estimate, but we can use these estimates to help us simulate actual things occurring. And then we can use probabilities based off of that. And that is the idea of a simulation. All right? So a simulation, and we're going to do more of this in the next lesson, but maybe look at a random number table. But this is simulations day 1, getting the idea of all the steps. We'll see you next time.